Hello students, today we will see group 16 in p block elements. So what are group 16 elements? Group 16 elements are oxygen, sulfur, selenium, tellurium and polonium. So oxygen, sulfur, selenium, tellurium and polonium are group 16 elements. So you can memorize all these elements by just combining all these alphabets to get a word like tipo. So using tipo, using that word you can memorize all these elements in group 16. So we need to study all these points first about group 16 elements. So in between I will discuss some questions also so that you can easily prepare for the examination. So first of all we will see a question, that is why group 16 elements are called chalcogens. So chalcogens are group 16 elements. Why group 16 elements are called chalcogens? So chalco means ore, gen means generating. So they are ore generating elements. So these elements are ore generating or ore forming elements. You know what is an ore? So many of the ores of metals are found in the earth crust in the form of oxides or sulfides. So most of the metal ores are in the form of oxides or sulfides. So we can say they are ore forming elements. Group 16 elements are ore forming elements. That is why they are called chalcogens. Now let us see the next point, that is occurrence. So first of all, oxygen. So oxygen is the first element, that is, it is the most abundant element on earth. So oxygen is the most abundant element on earth. But sulfur, in the case of sulfur, we can see different types of compounds, that is they are in the combined state. So sulfur may be in the combined state like sulfate or sulfides. So maybe in the form of sulfate or sulfides. They are actually gypsum, that is CaSO4.2H2O. The another one is Epsom, MgSO4.7H2O. Then galena, that is lead sulfide PbS, zinc blende, that is ZNS, zinc sulfide, barite, that is barium sulfate, copper pyrites, CuFeS2. So these are the combined form of sulfur, that may be sulfate or sulfides. So you have to study all these names and the formulae. So this is about the occurrence. Now let us see the next point, that is electronic configuration. So what is the electronic configuration of group 16 elements? So the electronic configuration, first of all we will write the electronic configuration of oxygen, that is the outer shell configuration will be 2s2 2p4. Then for sulfur it will be 3s2 3p4. So this is the outer shell configuration. Then selenium it will be 4s2 4p4. Likewise we can write the general electronic configuration of the valence shell of group 16 is, it will be ns2 np4. So ns2 np4 is the valence shell electronic configuration, that is a general electronic configuration. So ns2 np4 is the general electronic configuration of the valence shell of group 16 elements. So 4 plus 2, 6 electrons. 6 electrons are there in the valence shell. So 6 electrons are there in the valence shell. That is why it is in group 16. So S electrons are like this and P electrons will be 1, 2, 3 and 4. So this will be the orbital diagram of the outer shell configuration, that is S2 and P4. So Ns to Np4 is the outer shell electronic configuration of group 16 elements. So this is about the electronic configuration. Now let us see the next point, that is atomic size. Next one is atomic size. Atomic size is measured in terms of atomic radii or ionic radii. So atomic size is measured in terms of atomic radii or ionic radii. If it is in the form of atom, we will see atomic radii. If it is in the form of ion, we will see ionic radii. Anyway, both the concepts are same, but if it is an atom, it will be atomic radii. If it is an ion, it will be ionic radii. So we need to check the variation of atomic radii or ionic radii in a group. That is, down the group, we need to check the variation from top to bottom. So down the group, what happens to the atomic size or the atomic radii or ionic radii. So if it is an atom, we will see it is atomic radii. So down the group, what happens is, we know that if you are moving from top to bottom, we know that the atomic numbers are increasing or the number of electrons are increasing. So the number of shells are increasing. So down the group, number of shells are increasing due to the increase of number of electrons. So the distance from or the distance between the nucleus and outermost electron increases. So if the number of shells are increasing, the distance from the nucleus and the outermost electron increases. So atomic radii or ionic radii increases down the group. So we know that the atomic size will increase when we are coming down the group, since number of shells are increasing down the group. So the radius will be more in the case of, if you are moving down, it will be more in the case of the bottom element. So the atomic radii will increase down the group, or we can say the atomic size also increasing. So if it is in the form of ion, if it is O2 minus, S2 minus, Sc2 minus, etc. So this is also the same. So it is, these are the ions. So in this case also the same thing will happen, that is, the distance between the nucleus and the outermost electrons also increases from top to bottom, and the ionic radii increases from top to bottom. So the variation of atomic radii or ionic radii, or we can say the atomic size. So the atomic size increases from top to bottom. The reasons are, number of shells are increasing down the group, distance between the nucleus and the outermost electron increases down the group. That is why atomic size increases. So this is about atomic radius. Then the next point is ionization enthalpy. So ionization enthalpy. So what is ionization enthalpy? You know, the amount of energy required to remove the most loosely bound electron from an atom, or the amount of energy required to remove, or the amount of energy required to remove the outermost electron of an atom. So the outermost electron, energy required to remove the outer electrons from an atom, that is called a ionization enthalpy. So what is the trend of ionization enthalpy when we are coming from top to bottom in group 16? So what is the ionization enthalpy variation? So in this case also we will see the reasons. First of all, down the group what happens? First of all, atomic size increases down the group. You have already seen atomic size increases down the group. So the distance between nucleus and outermost electron increases down the group. So the outermost electron is far away from the nucleus when we are coming down the group. So that is the distance between nucleus and outer electron increases down the group. So we can say the attraction between the nucleus and outer electron decreases down the group. So if the electrons are far away from the nucleus, the attraction between the nucleus and the electron, that is decreasing down the group. So it is easy to remove the outer electrons from the atom. So if we are coming from top to bottom, the most loosely bound electron, that is in the outermost shell, it is actually far away from the nucleus since the atomic size is more. So the distance between the nucleus and the outermost electron is more, so the attraction is less. So we can easily pluck this electron. That is why the energy is less. So the needed energy is less in this case. So the attraction between nucleus and the outer electron is less. So the energy required to remove the outer electron will be less. Therefore, ionization energy will be less if we are coming down the group. So when we are coming down the group or in a group, or we can say from top to bottom, ionization energy decreases. So ionization energy decreases down the group. So that is about ionization enthalpy. So in this case we will see one question, that is we need to compare the ionization enthalpy of groups 15 and group 16. Group 15 and group 16. So if it is group 15, it will be nitrogen, phosphorus like this. Group 16, it will be oxygen, sulfur like this. So anyway, we will compare the group 15 elements and group 16 elements. So we know that if we are moving from left to right, that is in a period actually, the atomic size decreases in a period. So in a period, that means when we are moving from left to right. So that is group 15 to group 16. So in a period, the atomic size decreases. We know that atomic size decreases along a period. So if the atomic size decreases, the distance from the nucleus and outer electron decreases, or the attraction between the nucleus and outer electron decreases. That means they are attracted together. That means the outer electrons and the nucleus has an attraction. That means that is decreasing across a period. So more energy, if they are attracted by the nucleus, more energy is needed to pluck one electron from the atom. So ionization energy is more in the case of group 16 elements. So that should happen. So in a period, if you are comparing nitrogen and oxygen, so or phosphorus and sulfur. So if we are moving from left to right, we know that in a period atomic size decreases. and the distance from the nucleus and outer electron is decreasing. That means attraction between nucleus and outer electron decreases. So if it is decreasing, more energy is needed to pluck one electron from the outermost shell. So more energy is needed to remove one electron from the outer shell in the case of group 16. So that is when we are moving from left to right. So if it is if we are comparing 15 and 16, more energy is needed for group 16 elements, but actually this will not happen. So this will not happen. Actually it is decreasing. So the point is the ionization energy of group 15 elements, that is more than ionization energy of group 16. So we are expecting the ionization energy of group 16 is more due to the above reasons, but actually the ionization energy of group 15 is more than group 16. So what are the reasons? So this is an important question. So in this case we need to check the electronic configuration or the outer shell configuration. In group 15 it is having ns2np3 configuration, and this is having ns2np4 configuration. So in this case the orbital diagram may be like this, and in this case it will be like this. So this is np3, this is np4. So in this case we can see this is exactly a half filled configuration, a half filled electronic configuration. So this is not. So this is an exactly a half filled configuration, that means np3 configuration. So total number is 6 in p orbitals, so it is 3, that means it is a half filled configuration in the case of group 50. So if it is a half filled configuration, it is a stable configuration, or the atom is more stable. So the atom is more stable, So if the atom is more stable, more energy is needed to take one electron from that atom. So if it is more stable, it is difficult to take one electron from the outermost shell. So or we can say it is difficult to take one electron from the outermost shell of group 15 elements. So the reason is it is a half filled electronic configuration. That is the point. It is a half filled electronic configuration. So half filled electronic configuration is seen in the case of group 15. That is why it is more stable. But in the case of group 16, it is not a half filled electronic configuration. So this is stable. That is why we need to give more energy to take one electron from the outermost shell. That is why the ionization energy of group 15 is more. So that is an important question regarding ionization energy. Then the next point is electron gain enthalpy.